The goal of space enthusiasts has been to communicate with other intelligent species for a very long time, and we've been working towards that goal for the past 50 years. To make it possible for a wide range of messages to be sent and received, we have placed enormous radio transmitters and receivers in various places around the world. And now it seems our call has been answered. They sent us a heartbeat. To know everything about it, stick to the end of the video. Hello everybody, greetings from the Space Venture. Here, we introduce you to the wonders of the cosmos. We give you exciting and enlightening information on cosmic statistics and facts. Therefore, subscribe to the channel and don't forget to click the bell icon to never miss an update. With that said, let's get started. Researchers have discovered a puzzling signal coming from a distant galaxy. According to a recent study, a highly uncommon radio burst has been found. Its design resembles the beat of a heart. Currently, neither the precise location nor the reason for that sound is known. The signal is identified as FRB 201912221A and is a fast radio burst or FRB, which is an extremely powerful flash of radio waves that originates from an unidentified location. The new signal is substantially longer than other FRBs, which last only a few milliseconds at most. As a result, it is the longest FRB ever found. It also emits radio wave bursts that cycle every 200 milliseconds, similar to a heartbeat, making it the FRB with the most distinct periodic pattern yet discovered. The duration of these radio flashes detected in intergalactic space is 3 seconds or nearly 1,000 times longer than usual. One of the most intriguing cosmological mysteries at the moment is the origin of fast radio bursts. The eruption releases as much energy as 500 million suns in that little instant. Most quick radio bursts only flare once and then stay silent for a while. These can be predicted, therefore the only way to find one is to pray that it happens while a radio telescope is oriented in the appropriate direction. Repeated signals from one location in the sky are far less common. These are the quick radio bursts that repeat. Because they reoccur, researchers may use a telescope to observe the sky and examine the signals much more closely, though it's not obvious if all quick radio bursts are caused by the same mechanism. Intensity, wavelength, polarization, and dispersion are all variables. One fast radio burst in particular provides a critical hint. In 2020, a first radio burst was discovered coming from the inside the Milky Way for the first time. It was located in a particular kind of neutron star called a magnetar, indicating that at least some fast radio bursts may have been caused by these intensely magnetic ultra-dense objects. We're aware that this location is around 1 billion light-years away, or extremely remote in scientific terms, and they believe this to be an FRB. They are certain about this, since Earth-bound radio telescopes have detected it. They weren't found until 2007. The important mystery is where the source is, which is probably going to be a dying star somewhere in the universe. There are radio signals emanating from the dying stars, but it's crucial to understand where they are because if you find one as powerful as this one and pinpoint its location, you might be able to triangulate and determine how quickly the universe is expanding. Scientists had never witnessed it before in real life. It is more than simply a novelty or something from a movie, and the scientific world finds the recurring pattern and heartbeat sound very intriguing. Scientists were able to identify a magnetar as the source of the FRB in 2020. Neutron stars, which are ultra-dense stellar corpses left over from the violent deaths of stars, are a particular type that includes magnetars and are less dense magnetic cousins, pulsars. A beam of high electromagnetic radiation is emitted from the poles of pulsars and magnetars, which spin fast in space and resemble enormous lighthouses due to their exceptionally strong magnetic fields, which are frequently millions or trillions of times stronger than Earth's. However, it is not certain that all FRBs originate from magnetars. Due to their extreme density, magnetars and pulsars are likely to be the perpetrators in this intensity, which suggests that strong objects like black holes and neutron stars may be at play. The occurrences were formerly thought to be mostly ephemeral, since they appeared to occur only once and showed no indicators of a repeat emission. Astronomers didn't discover any proof of several bursts coming from the same source until 2016. Since then, several repeaters have been discovered, and some scientists have speculated that many FRB sources may frequently release bursts in patterns that are too complex for existing detectors to detect. The finding in 2020 that an FRB recorded has since been faintly repeated in 2 more recent times provided evidence in favor of this concept. Astronomers with the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, collaboration reported findings of the first FRB we are aware of that is recurring in a recognizable pattern. The FRB follows a regular cycle of hourly activity for 4 days, then 12 days of inactivity. FRB's mechanism remains one of contemporary astronomy's greatest mysteries, and there is still much to learn about them. The term Lorimer bursts originated from the discovery made in 2007 by American astronomer Duncan Lorimer. Only a few such instances have been seen since then in data gathered by radio telescopes all across the world, creating evidence that could lead to several different explanations. Only a few emissions have been located in specific regions of space, and the majority of them point to sources in distant galaxies. Between their source and Earth, these radio bursts decelerate as they travel through the atmosphere around the galaxies. Their radio frequencies are dispersed as a result of this. Researchers from the California Institute of Technology, also known as Caltech, used this to study galactic gas holes and discovered twice as much material than was previously thought to exist in these envelopes that surround galaxies. This has effects on how these assemblages of stars and planets change over long timescales. With the Canadian Hydrogen Intensity Mapping Experiment, astronomers examined a sample of 474 far-off FRBs and found that 24 of them were indeed slowed down in comparison to others that reached Earth unhindered. This effect can therefore be utilized to examine the substance that the FRB travels through. The investigation of the enormous gas reservoirs that surround other galaxies using more distant FRBs from outside our galaxy has already produced a surprise. The core of a neutron star collapses into an enormously dense object that is 20 kilometers across and up to an estimated 2.3 times the mass of the Sun, since it is no longer supported by the outward pressure of fusion. Likewise, a magnetar has an obscenely powerful magnetic field. Massive earthquakes occasionally occur in magnetars as a result of the magnetic field's dueling outward and inward poles. Neutron stars called pulsars emit radio emission beams from their poles that appear to pulse because they spin at speeds on the order of milliseconds. Scientists examined the bursts from FRB 20191221A and discovered characteristics shared with pulsar and magnetar emissions. The only issue is that, although the exact distance of FRB 20191221A is unknown, it is likely that it originated from another galaxy, because its outburst is almost 1,000,000 times brighter than magnetars and pulsars in our own galaxy. A second constantly active fast radio burst was reportedly found by an international team of astronomers, raising concerns about the nature of the enigmatic phenomenon. Fast radio burst 201-90520b, the new source, was discovered with the 500-meter aperture spherical radio telescope, also known as FAST, in Guizhou, China. Weaker, continuous radio emissions associated with the FRB were discovered through follow-up observations by the Jansky Very Large Area Program, which is run by Caltech. The Hawaii-based Sabaro telescope was also able to localize the source as being near the edges of a dwarf galaxy about 3 billion light-years away from Earth. The fact that the new FBR appeared to be an exact duplicate of an earlier discovery caught scientists by surprise the most with this discovery. Since the initial correlation between an FBR and a radio source seemed puzzling, many people think it might have just been a coincidence. The more recent second example, however, demonstrates that it might be a genuine and significant aspect of an FRB's existence. The finding prompts further inquiries into the nature of FRBs, including whether or not the sources of FRBs change over time or whether various sources can emit FRBs. MIT Cali Institute for Astrophysics and Space Research astrophysicist Daniela Micheli said that this discovery raises the questions of what may be causing such an extreme signal that has never been observed before, and how scientists can use this signal to understand the universe. When thousands more FRBs will be found each month by future telescopes, we might find many more of these periodic signals. The researchers are currently planning to potentially capture additional pulses from FRB 20191221A to learn more about the bursts and their enigmatic source. By doing this, the scientists could better understand the strange characteristics of neutron stars and look into what might be triggering the pulses. To determine where FRB 20191221A comes from and what might be causing it, the team is hoping to catch more outbursts from this enigmatic source. This could ultimately aid in our understanding of neutron stars. Anyways, we have arrived at the end of this video. Feel free to express your thoughts in the comments below. If you loved the video, make sure to hit that like button and also don't forget to share and subscribe. We'll see you in the next one again.